Hello, and welcome back to another episode of the Curiosity Monkey podcast. Apologies, it has been a while since we've last uploaded an episode. I think the last one was in October, but we are hopefully going to be getting back to a more regular upload schedule. So stay tuned for future episodes. And this episode I think is going to be slightly different because I thought I'd try adding some visual component in this time. On Spotify there's the option to upload video, and I'm going to upload this to YouTube as well, so if you're watching this on YouTube then hello. So I think hopefully adding some kind of visual aid will add something. Don't feel pressured to look at it. You can just listen along, and that's completely fine. There's no requirement to look at the screen. But so let's start with the topic for this episode, titled "A New Era of Climate Change Denial." Well, why are we doing this episode? It seems that there's been a rise in a new kind of climate change denial over recent years. It feels like I see this denial everywhere. Maybe it's just me, maybe online I am targeted with this kind of stuff with Google algorithms, etc. But it seems at least that this kind of denial is everywhere. And we'll get to what this new kind of climate change denial is and what potential causes for this shift are later on in the episode. But first, we should probably start with some basics on weather and climate. So what is weather and what is climate? So weather and climate are two different things. Things often confused. Weather is the atmospheric conditions at a given moment. So whether it's clear or cloudy skies, the temperature, whether it's raining, windy, humidity, in a specific region at a particular point in time. And the weather can change from moment to moment. So as I'm looking out my window here, it's fairly cloudy, sunny, fairly cloudy with a bit of sun coming through, but it looks like you could see some more clouds later. So the weather changes on short timescales, so it can vary quite quickly. And when we're talking about weather, we're really focusing on the lowest portion of the atmosphere where we're living, because that's where most weather occurs. And that area is called the troposphere. It's the lowest layer of the atmosphere, which extends up to 15 to 18 kilometers above the Earth's surface. It's where atmospheric circulation occurs. There's variation in this height. It's higher at the equator, where it's warmer, and lower down at the poles with denser, cooler air. So climate, in contrast, represents the long-term average of weather patterns in a specific area. So averaged weather over a long period of time, say 30 years, is typical. And when we're talking about climate change, we're talking about change to this average weather in a given position over time. So as we move into the future, the climate, they get shifts in the average climate. So what drives weather? So the sun bombards us as a planet with light. So light photons from the sun come and hit the surface of the Earth. Much of this light is absorbed by the surface of the Earth, and because light is energy, the surface warms. And the surface receives different flux of energy with latitude due to the axial tilt. So the equator receives the most flux on average, and as you move towards poles, the flux reduces as the angle between the incident sunlight and the normal to the surface approaches 90 degrees. So basically, the sun is at a normal to the surface, 90 degrees to the surface, you receive the highest energy flux. And note, because we're tilted on our axis, roughly 23 degrees, we see a seasonal variation. And so in the northern hemisphere summer, we have highest flux just above the equator, and in a southern hemisphere summer you have the highest flux just below the equator, and so the average flux is in the middle at the equator. And the difference in energy to the surface of the Earth at the equator and the poles, this differential heating. So the equator heats up more than the poles. This uneven heating will lead to variation in temperature, pressure, density, which drives the atmospheric and oceanic circulation, which then tries to redistribute this heat around. So this is really what causes weather. So what about climate change? Well, if you've listened to this podcast before, then you'll know that at least we've covered a few episodes on climate change related to topics, but the Earth's average surface temperature has been steadily increasing over the last couple of 100 years. So the Earth was an average 1.47 degrees Celsius warmer than the 1850 to 1900 average around now. So we are warming as a planet. The average temperature is increasing. And 2023 was the hottest year in record since record began, and now we're going into 2025. We can now confirm that 2024 was the new hottest year on record. And so the top 10 hottest years since records began, in order from hottest to coolest, was 2024, 2023, 2016, 2020, 2019, 2017, 2015, 2022, 2018, and 2021. So yeah, very recently. And I think we should make the distinction here that while global warming refers specifically to the increase in Earth's surface temperature, climate change refers to the increase in temperature and the knock-on effects to the weather. So how the weather will change due to the increase in temperature and the increase in energy that this planet has. And natural factors such as solar activity and volcanic eruptions can contribute to these changes. But the increase in carbon dioxide due to burning of fossil fuels, coal, oil, gas, petrol, has caused this change primarily. So we're seeing the increase in carbon dioxide concentrations over the last couple of 100 years in the atmosphere, and this is responsible for the vast majority of the change in average temperature. And the main driver for the rise in carbon dioxide is the burning of fossil fuels. There are some other ones that can cause, there are other factors that can cause effect, such as, say, there was a volcanic eruption in 1991, Mount Pinatubo released 20 million tons of sulfur dioxide into the atmosphere. Sulfur dioxide is converted into sulfuric acid, which can lead to reflectance essentially and reduce the flux to the surface, and that resulted in a drop in global temperature of around 0.5 degrees over the next 2 years. So other factors can have influence. In that case, that led to cooling, but the vast majority of warming is directly caused by the increase in carbon dioxide concentration in our atmosphere. And carbon dioxide is a greenhouse gas, and concentrations have been steadily increasing from 280 parts per million in 1850 to 419 parts per million now. So let's cover a bit about this greenhouse effect, because we know that carbon dioxide concentrations have been increasing due to burning of fossil fuels, and let's cover the mechanism at why carbon dioxide in particular leads to this increase in average surface temperature. So the greenhouse effect, you've probably heard it 1,000 times before, but for those who haven't covered this, it might be interesting to include it. So without a greenhouse effect, the Earth would be cold. So much colder than today, an average surface temperature of minus 18 degrees Celsius compared to our average right now of around 15 degrees Celsius. And the greenhouse effect works in principle by greenhouse gases like carbon dioxide and methane trapping heat into the atmosphere, causing warming at the surface. So you get an increase in net radiative forcing, which is essentially you're getting more energy in than energy out. So you get this warming. So how does this work? Well, like before, energy from the sun, in terms of light photons, come through the atmosphere. So light is able to pass through the atmosphere pretty easily. Say, when I'm looking out my window, I can see quite far into the distance. Not much light is absorbed by the atmosphere. A decent fraction of this light from the sun is absorbed by the surface of the Earth. Some is reflected, but a lot of it is absorbed. And as before, this warms the surface. And warm objects emit energy in the form of electromagnetic radiation, and this amount is related to the temperature. So warmer objects emit radiation at shorter wavelengths. So for the sun, the surface temperature is a few thousand Kelvin. It emits primarily in the visible light spectrum, but the Earth is only around 288 Kelvin, 15 degrees Celsius, and so we emit in the infrared spectrum. So the infrared spectrum is slightly longer wavelength than light. And it turns out carbon dioxide and other greenhouse gases, such as methane, water is also a greenhouse gas, are optically thick in this wavelength, so this means they absorb the photons at this infrared wavelength quite well. So any infrared radiation emitted by the surface is mostly absorbed by the greenhouse gases in the atmosphere. And the greenhouse gases will then re-radiate this energy in all directions. So some is emitted back out to the blackness of space, and some is emitted back down to the Earth's surface. And this therefore decreases the amount of energy leaving the planet. So you get a net energy gain and then a warming effect. And climate scientists have shown that basically all global heating over the last couple of 100 years has been caused by this increase in carbon dioxide. Because of the greenhouse gases humans produce, carbon dioxide is the most abundant one we're producing. So if you're using a car, you'll get the reaction between the hydrocarbon, the petrol in your car, and oxygen, which produce carbon dioxide in water. Now, I did mention that water is a greenhouse gas, but of the greenhouse gases, it has a very short lifetime in the atmosphere, and it's kind of kept in check by different negative feedbacks. So essentially, it can leave the atmosphere after only a few days, whereas carbon dioxide remains in the atmosphere for long periods of time. It doesn't just come out, so it's able to build up in the atmosphere. Well, water is regulated by the water cycle, so any water in the atmosphere can rain out, and it's regulated that way. But carbon dioxide builds up, and we emit a lot of carbon dioxide as humans at this point, burning fossil fuels for energy. So what effect is this warming having? Of course, we've got an increase in the average surface temperature, but it's not just global warming we're seeing. This warming is leading to a change in the climate. So what are we seeing? We've got changes in extreme temperature. So you've got temperature records being broken regularly. You also get changes in rainfall patterns. So this could be flooding or drought. Flooding can lead to economic damages from destruction of property and infrastructure. You've got drought leading to water insecurity and food insecurity from not being able to grow crops. Sea level rise from the thermal expansion and melting of polar ice sheets. We've seen a rise in about 0.2 meters in the last 100 years. More frequent and hotter heat waves. More frequent and severe wildfires. Again, food insecurity due to less productive harvests from droughts or extreme flooding. Increase in extinction events because plants and animals are unable to adapt quickly enough to changing conditions. So these are a few effects that the changing climate is having. And you've probably heard them 1,000 times before. So most people have seen that the increase in vast quantities of scientific evidence that humans are causing climate change, and climate change is having a net negative effect on us as a species and the other species we co-inhabit this earth with, and are concerned about this and think climate change is a serious issue. A survey from the Office of National Statistics saw that 74% of UK adults reported feeling at least somewhat worried about climate change. However, there are still a reasonable number of rather loud individuals who are spreading climate change denial content. So, climate change denial, what is it? Well, there are actually quite a few different ways that people can deny climate change. It's not just the rather obvious one, which is denying the existence of climate change or denying that humans have caused it. But there are other ways of denying climate change, and we will cover them later on in the episode. But in short, climate deniers will dismiss mountains of scientific evidence to create the illusion of a genuine debate over the legitimacy of existence of man-made climate change. And a common tactic is to dismiss the scientific consensus that human-produced greenhouse gases have led to an increased global temperature and then climate change. But the reality is climate change is happening, and there's overwhelming scientific data to support this. So what are the motivations for this? Well, you can probably get to them. You can probably guess them, but we will cover that on later on in the episode. And is there any merit to what they're saying? Is there genuine debate? Well, it turns out climate science is extremely well studied. It's perhaps one of the best studied areas ever. And this figure shows the number of publications released every year for the term climate change. Also, basically the number of studies published every year related to climate change. So there are hundreds of thousands of studies on the climate, and we are seeing there's a very high certainty that anthropogenic greenhouse gas emissions are responsible. So let's look at some common climate change denial claims, because there are quite a few, and these are the classic arguments that have been said over the past 20 years or so. So let's cover, say, the top three, and then there's a couple more, and then we'll get onto this new kind of climate change denial. So the first one, which is cited very frequently, is that there's no consensus and that climate scientists do not agree on the existence of climate change. So many studies have actually been done on climate change consensus, and it's found that between 97 and 99.9% of climate scientists agree that the Earth is warming, and this warming is caused by humans. And this has been shown time and time again. But then again, a lot of these deniers will claim that climate scientists will not tell the truth because their job is related to this fake science that they are creating, this publishing. So if they tell the truth and say that climate change is not real, then they'll be out of a job. Another common claim is that the climate has changed before, so what's the big deal? Well, indeed, the climate has changed in the past, but it's how it changes that differs. So the climate is constantly changing, but we find that it changes relatively slowly over the span of millions of years, and this allows life to adapt to these changes. The problem is when you have rapid changes to ecosystems conditions that result in species unable to adapt quickly enough. And we as humans depend on nature for survival. However much we like to separate ourselves from nature, we do depend on them. Although the climate mostly changes relatively slowly through time, we have seen instances in history where the climate has changed rapidly and naturally. And surprise, surprise, those were not great times in Earth and have resulted in some of the greatest mass extinctions we know about. And one example here is the Siberian trap eruptions, and these eruptions continued for a couple of million years, about 250 million years ago, and is thought to be responsible for one of the greatest mass extinction events, which is called the Great Dying. Doesn't sound too nice, where approximately 81% of marine species and 70% of land vertebrates went extinct. And the theory is that volcanic eruption after volcanic eruption triggered growth of methanogen bacteria that produced large amounts of methane, a potent greenhouse gas, and resulted in extreme warming of the Earth's surface. And that took around 9 million years to re-establish healthy new ecosystems after that. So that was a rather extreme event, but it shows that yes, extreme changes in climate is not so good for the species on the planet. The Earth itself will survive. Of course, it's just a large mass of rock with a an iron core and some tectonic plates that move. The Earth itself will be okay until it's swallowed by the sun, but the life on Earth will not respond too well to vast changes in conditions on the surface. And another one which is thrown around a lot, actually I see this is probably the one I see the most of the classic old denial, is that climate models are unreliable, so we cannot trust them or their predictions. So general circulation models work by solving the governing equations of the atmosphere and oceans. So what drives circulation due to energy from the sun, energy going out, the presence of carbon dioxide in the atmosphere. And so you're solving a set of equations, say the Navier-Stokes equations for fluid flow, mass continuity equations, thermodynamic equations, thermal continuity, chemical continuity equations. And we're getting a solution for what the temperature is at every point, the velocity components, UVW, the density, the pressure, different concentrations, say aerosols in the atmosphere. And anyone who has solved equations related to fluid dynamics, so there's nonlinear terms in the Navier-Stokes equations which make it a pain to solve. It has to be solved numerically and not analytically. And we find that the atmosphere and therefore weather is chaotic. So yeah, there are uncertainties, and that's why you cannot get an accurate weather forecast past 10 to 14 days. You see, those small errors will amplify with time. But the climate is an average state of weather, and it's much easier to predict this average state than an exact state. So if you're predicting a weather forecast, you're trying to predict the exact state of the atmosphere at a given time in a given space. But climate models, over long periods of time, you're trying to work out what's the average. What's the average going to be like in a few years, for example, due to, say, an increase in carbon dioxide. So you could model what happens if I double the carbon dioxide concentration in the atmosphere, and you're trying to find what the average result of that will be. And that is much easier to do than finding the exact solution. So climate models have been developing over the last few decades. I think the first ones, primitive models, started coming out in the 60s, and now we've got some pretty good climate models that do a good job. And there are uncertainties, sure. Aerosols represent quite a large uncertainty in climate models. It's quite hard to determine the exact effect of them. And there are uncertainties in climate models, sure, but the crucial point to make is generally what the models are predicting matches what we're observing. So yeah, we can trust climate models. Obviously, no models are perfect, they are models, and solving these equations is difficult and they always have limitations, but they are very valuable to studying climate change. And of course, there are a few other climate change denial claims which are commonly thrown around, one being the sun is brighter now, or it's warmer now, or the orbit has changed, so we're close to the sun. These stuff like this, reality, the solar flux reaching the Earth's surface, or the Earth's average orbital position, has been measured actually quite accurately for the past 40 or so years by satellites. And the solar constant has not varied that much, only varied by around 0.2% over the last few hundred years. So this is not the case. There are other ones. There's no evidence we've caused it, so it's down to natural causes essentially. Again, no evidence there really. A little warming is no big deal. The cold kills loads of people, so it's good that we don't have it's not as cold. Or everyone likes the sun, so it's great that it's warming. Or this is a particularly cold winter, please can we have some climate change, please can we have some climate change. These kind of things are thrown around a lot. But you get the general idea for this classic climate change denial that we've seen time and time again over the last 20 years or so. But we are now seeing a new kind of climate change denial. The new age of climate change denial is really what this episode is about. I find it quite interesting how these deniers are shifting their narrative. And so this is based from a report for the Center for Countering Digital Hate. And so it found that climate change deniers have been increasingly adopting new strategies to spread misinformation, moving away from traditional forms of denial. So the researchers analysed transcripts from around 12,000 climate-related YouTube videos, equivalent to around 186 days of content, published between January 1st, 2018 and September 30th, 2023. And these videos originated from 96 YouTube channels known for promoting climate change denial. And to identify denial claims, researchers employed a deep learning AI model that automatically analysed the transcripts. And the model's accuracy was, of course, tested, and it was found that there was 78% agreement between the researchers and the model. And the key findings were that we were seeing a decline in traditional forms of climate change denial. So the traditional denial in 2023 only accounted for 30% of denial claims, declining from 65% in 2018. The result from this is that climate change deniers are no longer denying the existence of climate change. They're denying climate change in a different way, and we'll get to what these new kind of climate change denial claims are in a second, but the gist is they are not denying the existence of climate change, or that humans are causing climate change. So this is a big shift from our old denial claims, whereas global warming is not happening, the ice isn't melting, the weather's too cold, it's so cold, the climate hasn't changed in decades, the sea level's not changing, or global warming is not caused by humans emitting greenhouse gases because there's no evidence of greenhouse effect. Those sorts of claims are not being said so much anymore. Instead, we're getting this new kind of denial, and there are a few different categories here. The first one is that impacts of global warming are beneficial or harmless. Say the climate sensitivity is low, or that the negative feedbacks are reducing warming, so the warming isn't that bad, or that plants and animals benefit from warming, or that carbon dioxide is beneficial because the earth is much greener, plants grow better in carbon dioxide. Photosynthesis requires carbon dioxide, so higher concentrations of carbon dioxide in the atmosphere mean that this is beneficial to plants, so you get more plant life. And there's other ones that, like, climate solutions will not work. So climate policies aiming to mitigate warming are very harmful. So building solar or wind farms is very bad for the environment, very expensive, worthless, and the cost to the economy is really bad and is reducing economic growth. Or climate policies are very ineffective, they're actually causing more harm than good. So building solar farms is causing destruction of farmland, for example, or that this renewable energy technology just simply doesn't work. So there's no point trying to add renewables to the system because they don't work, they're expensive. And the other one is undermining climate science by saying it's unreliable, or the climate movement is way over-exaggerating the problem. There's just a bunch of complaining liberals. And this is the new kind of denial that we're seeing everywhere on the internet. And it's not denying the existence of man-made climate change, but trying to undermine policy related to climate change. Why are deniers changing strategy? Well, some experts think this is happening because we are seeing the effects of climate change more and more firsthand, making it very hard to deny. It's just simply harder to deny something you are seeing evidence for. See, increase in the prevalence of droughts or periods of extreme heavy rainfall, such as we're having in the UK. It's much harder to make people believe something that they're seeing day to day with their own eyes. Which means we must see a change in tactics by climate action opponents so they can continue to delay climate policy. So who is promoting climate denial? Well, climate change denial is often propagated by several groups and organisations. And these include right-wing think tanks, media outlets, politicians who oppose climate policy, some individuals opposed to regulation, particularly those who resist government interventions and industry related to climate change. The oil and gas industry, surprise, surprise. It was actually ExxonMobil has known about climate change for around 50 years now, but spent decades funding climate denial groups. For example, the Heartland Institute, which is well known for rejecting scientific consensus on climate change, as well as they've also been known in the past for downplaying the negative health effects of smoking. So you kind of get the idea of who you're dealing with here. And of course, there are a few regular people who are influenced by the narratives of the above. So let's look at an example here. One that is quite relevant in the UK at the moment. I think I've seen actually a lot on this lately. Maybe it's just me probably getting targeted by different internet algorithms trying to make me see this content. But take Nigel Farage. He doesn't really directly disagree that the climate is changing, but argues that the effects are not that bad, or even positive, and that net zero targets are harmful. And he will claim that renewable energy transitions are doing much more harm than good. For example, we're in a cost of living crisis where energy prices are through the roof, and climate policy, he is arguing, is making everyone poorer. And the Reform UK Party manifesto falsely claims that climate scientists disagree over how much warming is occurring, and has campaigned for a referendum on the UK's net zero emissions target because he wants to scrap the policy entirely. And this is a quote from one representative of the party saying, "We are proud to be the only party that understands that economic growth depends on cheap domestic energy. And we are proud that we are the only party that are climate science realists." So they can reach hearts of many by saying that people's energy troubles will be fixed if net zero is scrapped. Because, of course, it's the environmental policy that's making the energy too expensive. But in reality, if we look at the pricing for gas electricity versus offshore wind electricity, we see that's £114 per megawatt hour 2025 for gas, and compared to offshore wind, £44 per megawatt hour. So you see there's a very large difference here. So the renewable wind energy, which can supply up to 50% of the UK grid on a windy day. So the UK is an island in the Atlantic exposed to a lot of wind, so we can generate a lot of energy from this relatively cheaply. But the marginal pricing system here means the wholesale cost of electricity is set by the most expensive method needed to make the demand, and that's usually gas. So the price of gas skyrocketed in 2022, while renewable energy costs, say solar and wind, have been steadily decreasing as the technology gets better and better. So the price of wind is lower than the price of gas at the moment. And of course, further innovation will bring these prices down further. But the reason the energy prices for electricity in the UK are so expensive right now is because it's priced off the most expensive thing burned or used to generate that energy, and that is gas right now. It's very misleading of Reform UK to suggest that it's the net zero policy that is making the energy so expensive, when in reality it's the gas. And Nigel Farage has been very vocal about trying to scrap net zero policy and issue more oil and gas permits for extraction of oil and gas around the UK. And by spreading this denial, he can gain support from a lot of voters, and he also has more to gain in the form of, you guessed it, money. The oil and gas industry has everything to gain with promoting climate change denial and undermining public trust in climate science, because if you don't sell oil, then you don't get profit. And they have known about the effects of burning fossil fuels on the environment for more than the majority of the public have known, like since the 70s, and have fought tirelessly to cover up the effect of climate change and their industry to prevent loss in profits. And the result of this is they've invested billions of pounds and dollars into groups who will write or influence people or politicians against anything that will oppose the fossil fuels, claiming that fossil fuels are required for cheap, reliable energy. So we get the fossil fuel lobby funding climate change deniers to fight against net zero policy. If we look back at Nigel Farage here, it turns out that Reform UK received more than £2.3 million from oil and gas industries upcoming to the election. So that's as of June 2024. So between December 2019 and June 2024, 92% of the party's donations came from fossil fuel interests. So no wonder why he was so against net zero policy and wanted to issue more oil and gas licenses. The Conservative Party has also been in the news lately for also showing some interest in scrapping net zero policy. And surprise, surprise here again, has received £8.4 million from fossil fuel interests since the 2019 election. And GB News is a right-wing news organisation here in the UK, and co-owner Paul Marshall's hedge fund, Marshall Wallace, had $1.8 billion invested in over 100 fossil fuel companies. And in the US, Donald Trump received over $32 million by oil and gas companies for his campaign to become US president. And as soon as he got into office, one of the first things he did was issue more oil and gas drilling licenses, saying, "Drill, baby, drill," and then reversed many climate policies implemented by Biden. So you can kind of get the idea of how the oil industry disrupting the rollout of net zero policy. Additionally, from 1997 to 2017, the infamous Koch brothers spent over $100 million in various organizations that basically attacked climate change science. So these industries, which hold a lot of money and value and profits to different shareholders, have everything to gain with promoting climate change skepticism, because you can generate more money this way. And hence, the oil industry desperately trying to disrupt the rollout of net zero policy, because if they cannot sell oil, then they will not continue to generate this profit. So they are a very large barrier to reaching net zero. Meanwhile, global temperatures continue to rise. So we are already feeling the effects of climate change. Some key examples of the last year which reached the news, for example in the US, Hurricane Helene followed by Hurricane Milton over Florida caused catastrophic flooding and damage. You've got the wildfires at the start of 2025 in California, hundreds of billions of dollars in damage to the destruction of property, infrastructure, people's lives ruined because of this. And both of these events were made more severe by climate change. With food, extreme heat and drought, or heavy rainfall has made it harder to reliably produce crops, and this costs us just in the day-to-day. So for example, chocolate, loads of people like chocolate, coffee, olive oil, oranges. So the hot, dry weather causing drops in productivity for cocoa and coffee, leading to decreased yields. So cocoa beans went from, in 2023, at the start of 2023 to April 2024, went up 5 times. Coffee beans from start of 2023 to now basically over doubled in price. Orange juice from 2023 to now doubled in price, more than doubled in price. So the climate is already having an economic impact as well as an environmental impact, and it is costing us in the day-to-day. So the future. The climate will continue to change as we continue to emit more CO2 into the atmosphere. And we will continue to emit carbon dioxide. We cannot just stop burning fossil fuels. I'm not suggesting that is the option. You can't just suddenly stop and go back to the Dark Ages before industrial times, but disruption of net zero policy is a large barrier to achieving net zero goals. And the truth is, we do have to reduce our emissions if we want to stop global temperatures from reaching our 1.5 degrees target. That is very optimistic to reach that, but maybe we can still reach the stay below 2 degrees target. And I think a lot of people today are rightly concerned about climate change, but still fossil fuel interests will continue to fund against net zero policies. But again, with all of these things, if you see articles in the news that seem to put some distrust in climate science or against net zero policy, have a look into the authors or the publishing company and see where is that money coming from. Are they being funded from other interests? Admittedly, it can be difficult because these fossil fuel companies can often donate anonymously, which makes the money harder to track. But always think critically about what are their interests in this. Do not be too sad. Do not be doomist about the climate. There is hope. Be optimistic. Since 2012 to now, the UK's the electric grid has decarbonised, so it's about a third of what it was in 2012. And this is because we have shut down all of our coal-powered stations for generating electricity, and this has resulted in a reduction in our emissions. And we've also increased the amount of wind. So, as I say, on a windy day, we can produce up to 50% of our electricity from wind. I hope you enjoyed this episode of The Curiosity Monkey. I found it quite interesting because this is something I have seen a lot online. Again, maybe it's just me because as someone who's interested in climate science, I'm sure that the internet, specifically Twitter, likes to throw things that are more polarized or / outrageous towards me to make me feel stuff. But I find it quite interesting. I hope you did as well. And of course, if you enjoyed this episode, please do not hesitate to like or comment or follow us. We're also on Instagram at The Curiosity Monkey. You can email us at thecuriositymonkey1@gmail.com if you have any suggestions or episode feedback. We're also trying to publish stuff on YouTube now, so this episode will be on YouTube. Hopefully the visual part made it more engaging and more interesting. Hopefully I can get that to work. I've never done this on Spotify. But hopefully this will successfully upload as a video on Spotify. But as always, thank you for listening and stay curious.